important role in what electrical signal. Okay, and being in this engineer now, so we deal with what the flow of electrical power only, right? That's why power, you know that for power, when you define power mathematically, so is V into I, right? So voltage is there, then current is there. So if voltage is there, it means that the electric field is there. And if free electric particle is there, then under the influence of that electric field, that particle will move from one point to the other point and the current will be set. And if the current is there, so we can say that now there is flow of power, electrical power. Okay, but the current, it generates what? Magnetic field. So that's why talking about electric field and magnetic field is very important in this area. And these two fields also forms what? The wave. Okay, right? Because your current and voltage, they can be, at least current, I can say, current is always confined to what? Conducting medium. But wave, it is independent of that. Once it has got detached from that conducting medium, then it can travel anywhere in the atmosphere as long as it carries energy. Okay. So let's see what is the electric field. We'll try to explain electric field in various form. Okay. So we'll begin with what is written here. It's a measure of amount of force exerted per unit of test charge at some point in space.
Excuse me, sir. So most of the students are in the waiting room. So can you let them in?
I can see that there are 10 students are there. They are admitted. Okay, so it's a force per unit charge in simple way. Okay, force ka already we have discussed what is the force, actually electric force. So if it is a here, a measure of the amount of force exerted per unit test charge at some point in space is nothing but your field intensity, electric field intensity. Okay, and in a similar way also you have to define magnetic field intensity also. So here this capital Q is one charge. Okay, and there is another charge which is called as test charge, but it's written as Q naught. Okay, small q naught, not the capital one. Capital means we are talking about significant amount of charges there, but when we talk about test charge, it's a theoretical concept. Practically it is not existing. Okay, so it's totally hypothetical test charge. It is so small that the amount of charge, it approaches to zero. That is how we treat this test charge. Okay, so first we'll try to understand mathematically what is this field intensity, and later on I will tell you the physical meaning of that. Okay, because that is more important. Because if you're not aware how this the field looks like, not looks like exactly what, if you're not able to feel it, then it will be difficult to understand what is happening in EME. Okay. Students, they are coming in between us, so it is disturbing me a lot. Okay, so here there is a charge Q, okay, the star shaped, okay, and it is exerting some force on small charge, that is Q naught, okay, and this is the red color. It shows the direction in which the force is experienced by that small charge. Okay. So Coulomb's law for this force is what? It is product of the two charges which are interacting with each other divided by 4 pi epsilon naught r square. Okay. This is the simple definition, mathematical definition of the force, electrical force between the two particles. One is what? Your Q, capital Q. Another one is what? Q naught, that is test charge. Okay, but if I have to define electric field intensity, so it is force experienced by the test charge. So that's why it is written as what? F divided by Q naught, right? this becomes what your field intensity. So of course, the unit of the two quantities, they're going to be different because both are different. One is talking about the force and one is talking about the intensity. So force, it's Newton. So here it is going to be Newton per Coulomb. Okay. There are other units also, like you can here see a Coulomb. Two charges are there, so Coulomb square divided by 4 pi. 4 pi is a constant. Epsilon, it has got another unit. Then r is the distance of separation between the two particles, so it will be in meter. Okay, so you can have the other unit also, but the simplest one will be what Newton here, and here it is Newton per Coulomb. But we don't use this electric field intensity as what Newton per Coulomb, because we are from electrical background. Okay, so we deal with what voltage and current. So at later stage you will find that electric field is expressed in the form of what the voltage, in the unit. It's volt per meter hota hai. We'll see how that volt per meter comes actually. Okay. So finally, yeah, if I substitute this F there in the lower equation, electric field equation, so Q naught and Q naught will get cancelled out. You will get what? Q by 4 pi epsilon naught R square. Now it will check, see or observe the difference between F and E. So F, it will exist only if the two particles are there, but the electric field intensity is going to exist only if it's alone that electric field can exist if the particle is there. There is a difference between these two. Okay. And if you have any query, please you can ask in between also. I don't have any issue. So this is the mathematical way to define the electric field intensity. Simply, you have to say that electric field intensity is nothing but the force experienced by a unit charge, unit test charge. Okay. And it is given by Q divided by 4 pi epsilon naught R square, or in general epsilon naught. Here it is epsilon naught written because we are considering the vacuum. Okay, so it's epsilon naught. Otherwise, it will be epsilon only. Okay, so if you have any query related to this, you can ask. Otherwise, I will move ahead. Okay, fine. Okay, now the electric field lines are there. It's better that now I should must explain the actual the meaning of electric field intensity. Mathematically, we have seen, right? But physically, what is that? Presentation one.
Sir, can you please record this meeting?
Oh, I'm sorry, I'm a actually every meeting should get recorded.
Recording in progress.
Recording pe dal diya maine. You will get it.
Yes, sir.
Who was this?
Sir Gaurav.
Okay, Gaurav. So let's, can you see a blank screen here? I've shared a whiteboard actually. Not whiteboard, PPT ka hi blank screen hai. Is it visible?
Yes, sir.
Yes, sir.
Okay. ठीक है. I'm using this pen tab for the first time. हाँ, so थोड़ा neatness में issue आएगा या फिर speed में भी आएगा. But of course, later on, कुछ problem नहीं आएगा. I hope so. Okay. So let us understand what is this electric field intensity is actually. Okay. Electric field. So mathematically, it was written as what? That electric field intensity is nothing but Q divided by 4 pi epsilon then R square. Okay, it's a vector quantity actually. So I have to give some direction also, right? Like this. But and the difference also between the electric field intensity and the Coulomb's force was discussed, that when we talk about the Coulomb's force, so there is involvement of two particles. But is it so that this force will not be existing in nature if a single particle is there? So because if the two particles are there and they are experiencing force of attraction or repulsion because of the other particles, it means that individually they are existing and they are creating their impacts in the surrounding. Okay, so alone, if I have to look at any particle, then in what way it is creating its impact in the surrounding. So whatever impact it is creating in the surrounding is nothing but your electric field only. Okay, electric field intensity. Okay, and that effect is created with the help of what? The field. Okay, so now what I'm trying to tell you that in what way we are going to see at look at this electric field intensity, that if a single particle is there, then in what way it is going to create its impact. So to understand this, now you can take a simple example. Let us consider that you have a sphere, okay, like this, right? And it is what? It is heated to a very high temperature. Let us consider that up to 1000 degrees centigrade. Okay? And because of which, what is happening, that it is radiating out heat, right? Now, whether this body is heated or not, how to identify this? Any answer?
Radiation.
But see, it is going to radiate, but how you will come to know that whether it is getting
फील होगा इतना होगा तो गरम
कोई एक टाइम पे एक ही पर्सन बोलो तो
मैं फील होगा इतना गरम होगा तो मतलब हाथ से
मींस फीलिंग चाहिए ना फील कैसे होगा फिर फीलिंग के लिए भी कुछ मैकेनिज्म रहेगा राइट मींस सी इफ योर skin is not sensitive to the heat, then you won't be able to tell whether this body is heated or not.
यस सर
ठीक है, तो हम लोग क्या करेंगे, अभी हम लोग उतना रिस्क लेंगे नहीं. सो विल व्हाट डिवाइस समथिंग. सो मैं क्या करूंगा, यहाँ पे एक टेम्परेचर मेजरमेंट के लिए कुछ तो ले लूंगा मैं. जो भी अपने पास रहेगा, थर्मामीटर वगैरह.
सर थर्मल सेंसर लेंगे ना?
कुछ भी ले सकते हो, एनीथिंग व्हिच इज सेंसिटिव टू द हीट, राइट. तो नाउ सी हियर आई हैव केप्ट वन थर्मामीटर, मर्क्यूरी वाला. ठीक है, एंड इफ the mercury level rises up, so I will come to know, okay, the body is heated actually because the temperature is above the normal atmospheric temperature, and if I place it very close, then it will further increase. Okay, and finally that thermometer will break down because of the high temperature. Okay, so here this situation you can compare with what Coulomb's law, that one particle is what your this one. Okay, the heated body, another particle is a thermometer which is capable to sense it. Okay, and there is interaction going on between these two, just like the force of attraction or repulsion between the two particles. So whether the force of attraction is there or repulsion is there, for that you have to have another particle in the vicinity of another particle, then only you will be able to say which force of attraction hai or repulsion hai. But if suppose the body is what acting alone, a single particle is there. Now if you want to check that is it that this particle it's creating its impact in the surrounding or not. Okay, so the moment you bring another particle to check it, because see, like for in this particular example, heat can be sensed only if you are having something which is sensitive to the heat. Then only you can say that the body is heated or not, or up to what temperature it has got heated. Okay, so that kind of arrangement is required. Similarly, in the field of electrostatic also, if suppose you want to check the impact created by a particle. Okay, so I will bring that particle here. It's Q. Okay, it's placed here. So what kind of impact it is creating? So if suppose I say the moment I will say that, okay, it's Q, another Q, suppose I will call it Q, and this is one. So the moment I will bring it here, another particle. So what is going to happen that this particle, the Q2, is going to disturb its original nature of Q1. So if it is getting disturbed in all respect, its position may get disturbed because now the two particles, they are like particles, so force of repulsion will be there, so it may get shifted somewhere here. Okay, so the distance between the two particles will get increased, right? So the impact created by this Q1 when it was at this location, and the impact created by the same particle when it is at this location, and it is tested at this point, will be different. Okay, so bringing another particle is not advisable. But of course, if you're not bringing another particle, then it is impossible for you to tell what kind of impact this particle is creating, right? So what we do, instead of taking this kind of this charge, which is capable to disturb the original charge, okay? So what we do, we take a test particle. Test particle, okay? It's very tiny. Tiny means what? Its charge is almost zero. It approaches to zero. It's not exactly zero. Now remember that this pure theoretical concept. Pure theoretical concept. Actually, it is not existing, but this particular tool has helped the engineering community to understand in what way a single particle can influence the surrounding. Now the distance between this particle and the next particle is what? That is here to here. That's R. Okay. So first, now since even though it is very small particle, but of course it is capable to sense. Now the reason to involve this small particle is that this particle is now not creating a very significant effect, so that the Q1, it will get dislocated from location 1 to location 2. It will remain there only. Even if there is a change, then that change in the location will not be very much significant. So its original location is not dislocated, okay? It's not changed. So whatever impact it is creating at location 1 to at this point, that will not get disturbed. This is one thing. Second, when we talk about the other kind of disturbance, so now if this is that particle, let us consider, okay, like this. So every particle is going to create its impact with the help of the field which are radiated by that particle, like this. Okay. So if suppose you are bringing another particle here of similar nature and of significant value, like this. So what is going to happen? The field which was expected to go like this, it will get bent like this. Okay. Bending of the field, and this also will.
Sir, if the charges will be like, then it will bend, right?
Right. Like this. Okay. So here in between there won't be any force actually. यहाँ पर कुछ भी नहीं रहेगा, बीच में कोई भी field नहीं रहने वाला है. And we take the example of like charges because that is simple to explain. So यहाँ पर कुछ force मिलने वाला नहीं है आपको. So you can see that the involvement of the second particle is actually disturbing the first particle, the particle in which we are interested, and we want to know what kind of impact it is creating in the surrounding. So we don't want to create this kind of situation. That's why what we do that we bring a test particle. Test particle is not that strong. Okay, it's because I have already written here that its magnitude approaches to zero. What will be the nature, whether it's positive or negative, but its magnitude is so small that your original particle is not get disturbed. Okay, so So the electric field, now because there is involvement of the two particles, so the force of attraction or repulsion is going to be there. Okay, and this force is experienced by what? The test charge. Okay, and here limit delta Q approaches to 0, that I have to write, and later on I will substitute all this. So Q delta Q divided by 4 pi epsilon naught and r square into 1 by delta Q. So these two get cancelled out, and you get what? Q divided by 4 pi epsilon naught r square. So the meaning of this equation is that whether the second particle is there in the atmosphere or not, but if a single particle is available at any place, then it is going to influence the surrounding medium, and that impact or influence is always referred as what? Your electric field intensity. It is inversely proportional to the square of distance and directly proportional to the amount of charge. Okay, just like your heated body. So even if suppose you are not using any measuring instrument, so it doesn't mean that the body is not heated or it is not radiating. It is going to radiate because its temperature is higher as compared to the surrounding. So measuring instrument try once it is heated, so of course it is going to create its impact in the surrounding. Okay, whether you measure it or not. Like sun, we are knowing that it radiates because अपने पास tools है, हम नहीं तो अपना skin ही एक अच्छा tool है, we can sense it. Okay, so but if suppose ऐसा कुछ living body है नहीं जो heat को sense करे, but ठीक है, तो इसका मतलब ये नहीं हो जाएगा कि the sun is not creating its impact in the surrounding in the form of heat. It is creating. So same is true with the electric field intensity also, whether the second particle is present or not. If a single particle is there, then also it is going to create its impact in the surrounding medium. Of course, the impact, whether it will decrease if you move away from that source of the impact. In our case, it is what? Charged particle. Now that decrease will be linear or non-linear, that depends. Okay, क्या equation मिला है, तो उसमें Coulomb, he guessed it very rightly. Actually, it was guessing only. 1 by r square, and it was his guess actually, but इतना fantastic guessing किया था उसने कि later on when people they try to find out कि r square ही क्यों होना चाहिए, cube वगैरह क्यों नहीं होना चाहिए, so they agreed कि r square is sufficient to get sufficient amount of accuracy. Otherwise उसके बाद cube वगैरह भी आता है, अगर आप अच्छा रेफर करोगे पेपर्स वगैरह, उसमें क्यूब का भी बात करते हैं हम लोग, लेकिन बोलते हैं उतना कॉम्प्लेक्स हो जाएगा इक्वेशन, उसका जरूरत नहीं है अपने को 1 by r square.
I have one doubt regarding this. So why do you use inverse square law? That was like one was used by Newton, but when we come to charges, it doesn't depend. The size of the charges is too small, so the inverse square law will work or not.
Can you repeat? The voice is not very much clear.
Sir, I'm audible now?
हाँ, you are audible, but clarity नहीं था voice का.
Yes, sir. I have that doubt, like how these tiny charges will be worked, that inverse square law, which was proposed by Newton.
अच्छा, न्यूटन में भी r इनवर्सली प्रोपोर्शनल टू r स्क्वायर आता है ना?
Yeah, right.
हाँ, तो ऑफ कोर्स वो जो मैं भी आपको थोड़ा
That
बताया था
was for
इंसिडेंट,
two huge bodies.
टू
like,
ह्यूज बॉडी, राइट राइट.
Yeah.
तो जहां तक मैं समझता हूँ ना कि जब कोलम व्हेन ही वाज वर्किंग ना, he just thought to have that kind of this इक्वेशन कि जैसा न्यूटन ने लिया है वैसे इसमें भी रहेगा. अभी वो एक कोइंसिडेंट हो सकता है क्योंकि उसको भी नहीं मालूम था कि वो इनवर्सली r स्क्वायर डालेंगे तो प्रॉपर होगा क्या नहीं. लेकिन बाद में जो रिजल्ट्स क्योंकि कैसा है कि अगर आप कुछ मैथ्स का इक्वेशन अगर आप डेवलप करते हो, ठीक है, तो आपके माइंड में कुछ तो चलता है, कुछ एक बैकग्राउंड क्रिएट करते हो, उसके बेसिस पे वो आप इक्वेशन लिखते हो, और उसके बाद क्या होता है कि वो इक्वेशन कितना वैलिड है अगर फॉर्मुलेशन के बेस पे चल रहा है. मैं इसकी बात नहीं कर रहा हूँ जैसा कि डिफरेंशियल इक्वेशन है, डिफरेंशियल इक्वेशन की बात नहीं कर रहा हूँ मैं. अगर मुझे कोई जैसा इस चार्ज का ये कि भाई मुझे पता चल रहा है कि टू बॉडीज आर देयर विच में रिपल इफ द लाइक चार्जेस आर देयर, ठीक है, उसके लिए भी कुछ एक्सपेरिमेंट हो रहा है कि लाइक चार्ज है कि अनलाइक चार्ज है, वो सब भी किया गया है. देन लेटर ऑन इट वर कंक्लूडेड कि लाइक चार्जेस रिपल करते हैं, अनलाइक चार्जेस वो अट्रैक्ट करते हैं. तो भी फोर्स कितने फोर्स से अट्रैक्ट करेगा, रिपल करेगा. तो और भी एक्सपेरिमेंट करके पता चला कि दोनों के के ऊपर डिपेंड करता है, देन डिस्टेंस इज ऑल्सो देयर। तो उसके बाद का जो इक्वेशंस है कुछ जैसा 1/r² का पार्ट है, वो तो जहाँ तक मुझे याद है जो मैंने पढ़ा था उसमें वो प्योर गेसिंग के बेसिस पे था। और उसके बाद फिर टेस्ट किया गया कि ये जितना फोर्सेस वगैरह जनरेट होता है उसमें R² जो डाला गया है वो कितना एक्यूरेटली काम करता है। तो उस टाइम पे उतने टूल्स तो नहीं थे इतना एक्यूरेसी के लिए, लेकिन जो भी उनको रिजल्ट मिला उसके बाद लगा कि नहीं, ये R² प्रॉपरली वर्क करता है। तो कुछ चीजें हम लोग कैसा दूसरे फील्ड से बोरो करते हैं, जैसा अभी इलेक्ट्रोस्टैटिक का है, तो अभी वो न्यूटन्स के लॉ से कि अगर आप उसका फार्मूला इसका फार्मूला कंपेयर करोगे तो सेम ही लगेगा फार्मूला, कुछ खास फर्क नहीं दिखने वाला है उसमें। तो उसमें ग्रेविटेशनल कांस्टेंट आ जाएगा, ये 4πε की जगह पे बस उतना ही डिस्टेंस डिफरेंस है, और चार्ज की जगह पे मास आ जाएगा।
यस सर,
तो
राइट।
कुछ वो चीजें वहां से एज इट इज बोरो की गई थी।
तो
और
सर
लेटर
आज ये
ऑन,
वैलिड है इक्वेशन?
हाँ हाँ, अभी इसमें हायर वर्जन्स भी है इसके, जैसा मैंने बोला ना 1/r² तक ही लिमिटेड नहीं है, क्यूब में भी है वो। लेकिन बोलते अगर वो क्यूब लेके अगर आप पूरा अगर EME थ्योरी आप डिजाइन करने जाओगे ना तो चीजें बहुत कॉम्प्लेक्स हो जाती है। तो जबकि 1/r² से आपका काफी एक्यूरेसी भी मेंटेन होता है और सिंप्लीफाइड भी हो जाता है, तो क्यूब वगैरह तक जाने का जरूरत नहीं पड़ता है। अदरवाइज थोड़ा एरर है, मुझे एरर का भी मेरे ख्याल से वो ऑथर का नाम है कॉर्सन, और बुक इलेक्ट्रो, अभी टाइटल बुक का याद नहीं, बट इट इज इलेक्ट्रोमैग्नेटिक के ऊपर है। उसमें उन लोगों ने ये पॉइंट रेज किया हुआ है, क्यूब वगैरह क्यों नहीं हो सकता है। तो दोनों चीजों में उन लोगों ने एरर दिखाया कितना एरर होता है, तो एरर वो इतना स्मॉल था क्यूब लेने पे, मीन्स आफ्टर R² क्यूब टर्म भी आना चाहिए, उसके हायर टर्म्स भी आने चाहिए। तो वो जो एरर था वो इतना नेग्लिजिबल था कि बोले R² इज सफिशिएंट टू डिफाइन इट, दैट्स व्हाई कूलम्ब्स का जो लॉ है वो 1/r² पे वर्क करता है। सो नो नीड टू गो फॉर क्यूब एंड हायर टर्म्स ऑल्सो।
ओके।
अच्छा, अभी न्यूटन में इसमें दो पार्टिकल्स के जो बीच में जो ग्रेविटेशन है वो तीसरे के आने से इफेक्ट नहीं होता, ऐसा बताया ना। लेकिन ऐसा इसमें भी नहीं, इसमें नहीं है क्या मतलब?
आएगा आएगा, सब आएगा। एक पार्टिकल कैसा है कि अगर एवरी पार्टिकल इंडिविजुअली दे आर क्रिएटिंग इट्स इम्पैक्ट इन द सराउंडिंग ना, तो उसके सराउंडिंग में जो भी आएगा वो इन्फ्लुएंस होने ही वाला है। बट वो कैसा है कि ये जो इक्वेशन है वो इतना लीनियर है ना कि आपको खाली एडअप ही करना है, ज्यादा कुछ चेंजेस नहीं करना है, सेम फॉर्मूला बट थिंग्स विल गेट एडेड, दैट्स इट।
ओके सर। सर और ऐसा साइंटिस्ट है जिन्होंने प्रूव नहीं किया लेकिन उनको पता था ऐसा है और बाद में वो मतलब बराबर प्रूव हुए हैं, ऐसे
किस किसके बारे में बात कर रहे हो आप?
मुझे एग्जैक्ट याद नहीं आ रहा क्या था, लेकिन ऐसा सुना था एक, मतलब कि उसको सिर्फ पता था कि ऐसा ऐसा है और वो बाद में प्रूव हुआ, उसने प्रूव नहीं किया था।
ओके ऐसा बहुत सा है इंसिडेंट। मैथ्स में जाओगे तो रामानुजन का 4000 फार्मूला आज तक लोग प्रूव ही कर रहे हैं, जबकि उसने वो इक्वेशन लिख के चले गए हैं।
यस सर।
मैथ्स में आपको ऐसे मिरेकुलस चीजें हैं ना बहुत सी मिलेंगी, जैसे सोलर प्लेनेट, सोलर सिस्टम में लास्ट प्लेनेट है, वो उसके एक्चुअल डिस्कवरी से 20 साल पहले ही मिल गया था। बट वो रशियन मैथमेटिशियन ने पेपर पे फाइंड आउट किया था कि 9 प्लेनेट हैज टू बी देयर, अदरवाइज सोलर सिस्टम कोलैप्स हो जाएगा। 20 ईयर्स के बाद पता चला वो। और आप अगर हजारों साल पहले चले जाओगे तो अपने पंचांग वगैरह में सब कुछ मिल जाएगा आपको, ऐसा है। ओके
सर सॉरी टू डिस्टर्ब बट बहुत लोग वेटिंग रूम में मैसेज आ रहे
हाँ देखा मैंने
हैं। हाँ सर।
वो, एडमिट कर लिया उनको। वो क्या बीच बीच में आते हैं ना मुझे, फिर एक तो मैं वो पेन टैब यूज कर रहा हूँ तो एक मोड से।
सर वो एक्चुअली मीटिंग एंड हो गई थी ना, तो बाद में सब ज्वाइन किए तब आपने मतलब एडमिट ही नहीं किया था
ओके
जल्दी।
ओके ओके। नहीं मुझे लगा कि क्योंकि अगर एक होस्ट है को होस्ट है, तो अगर को होस्ट चले गया तो
शास्त्री सर,
हाँ।
मुझे कोर्स बनाइए तो आई कैन एडमिट देम। आई एम
एक
नॉट
मिनट,
स्टिल, आई एम नॉट को होस्ट। हाँ,
ओके
एक्चुअली
ओके,
मीटिंग मैंने स्टार्ट की थी बट आई डोंट नो समहाउ आप
वो
होस्ट
शायद आप
बना
लॉग
रहे
आउट हो गए थे इसके लिए।
हो। हाँ हाँ।
ओके, बहुत स्लो काम करता है वैसे. Now your co-host, ma'am. Okay, so we have finished electric field definition. Next is the way the electric particles, they are going to influence the
Sir,
surrounding.
screen sharing is stopped.
Sorry.
Yes, sir.
I didn't share actually. Now it's visible.
Yes, sir.
Okay.
Yes, sir.
Okay, so electric field. Now here charge particles, positive and negative. So you can see the uniformity in the distribution of the field. If the medium is isotropic in nature, then only this kind of field distribution is justified. If the medium changes, then the distribution of the field, whatever lines of forces which are coming out or going inside this particle, that will get changed. And metamaterial जो मैंने example applications में दिया था ना, they are artificially created material which are going to bend the direction of this electric flux radiated from the charged particle. Okay. Anyways, electric field here. So it's because it is electric particle. That's why the field radiated out from this particle will be what? Electric in nature. So this is we are talking about what? Isolated particle, but very rarely we come across this kind of situation. With single particle, or you can have a sphere of particles. Means all millions of millions of particles, they are accumulated at one place, and they are almost forming a shape of sphere. So at that time, the field which will be radiated out, or the field which will be falling on this group of particle, they will be distributed uniformly, okay, spherically, जैसा दिख रहा है यहाँ पर. So this is just for the sake of visualization. So if you are coming across a situation like this, so you must be able to visualize कि वो कैसा होगा particle का field, and if some other particle comes, then in what way the field will be changing its orientation or alignment or distribution in the space. But remember that this distribution of field is valid as long as the medium is isotropic in nature. Means in all direction, the property of the medium is not changing. If the medium of the property changes, then the distribution of the field is going to change. And the same concept is used in what? Your designing of capacitor. Capacitor में हम लोग वैसा dielectric material डालते हैं जिसकी वजह से field का distribution change होता है. Okay, radially outward, that is okay. Superposition of electric field. Okay, if more than one particle is there, then what is going to happen? Okay, so here, if suppose there are 3 particles in the surrounding, and you want to check what is the impact created by 3 particles at point P. So you can individually find out the impact created by individual field, and you can add, because the nature of the equation is what? Linear. That's why you can add it. Okay, and the red one represents the resultant direction in which the electric field is existing, electric field is working. Then now, as I said that you will never or rarely you will come across what? A single particle का concept. Generally there are what? Group of particles. Single particle का concept आपको एक और इसमें मिलेगा. That is what? आपका printer, right? So whatever inks, droplets are coming out of that machine, they are charged particles. So there you can apply the concept of single electric particles. वहाँ पे चल जाएगा. Okay, otherwise नहीं. Now, so we are having the practical scenarios, but remember that practical life उतना भी easy नहीं होता जितना हम लोग यहाँ पर simplify करके बताते हैं. Practically, you may come across what? Other distribution of other kind of distribution of the charges. Like first one is what? The line charge. Okay, so simple example is what? Cable. Cable, when they are carrying electrical signal from one place to other place, so they are charged actually. Okay, means they are carrying this electric particles along the entire length. So this is one of the example here. Now, since here electric particle, it is distributed along the line. So there is not a single particle, okay, Q, which is involved, but the group of Q is involved there, right? So we have different definition of this, the way the charge is distributed. So we call as what? Line charge density. Because there are now more number of particles and they are fitted in certain length. So of course, it becomes what? Density, but line charge density. So it's the density is represented with the help of what? Rho. Okay, so here you can see that rho is written, suffix L is there. L means the line. Okay, so rho is what? It represents that now we are not talking about the single particle, but group of particle. They are fitted in some confined space. Okay, that's why it becomes what? Density of particle. So density of the particle, but the density of particle is along a line. So line charge density. So it will be what? Total amount of charge distributed along the line divided by the length of the line. So unit becomes what? Coulomb per meter. Okay. So it's a line charge density. Just keep this in mind. Then continuous charge. Another one is what? Surface charge density. Now the charges, they are spread throughout a sheet. So this simple example is what? Of capacitor. So when you go for the analysis of the capacitor or designing of the capacitor, so at that time you have to take what? Surface charge, this concept. You cannot talk what at what individual level of the charges. There are amount of charges which are uniformly distributed along the surface. Okay, so surface charge density. Now, since it is the charges, they are distributed or they are confined on certain area. So it's once again, it becomes what? Density. Okay, so now the surface charge density is once again, now it is not rho L, it is rho S because the surface is involved there. So rho means what? It's charge density. We are talking about certain charge density. But if it is line or surface, you have to specify. So it is S. So Q divided by surface area A. So unit becomes what? Coulomb per meter square. Okay, so this also you have to remember that. Now the distribution of charges are what? We started with a point charge. Then we talked about what? Its impact created in the surrounding. And that impact is always measured in terms of electric field intensity. Then, as I said, that you are going to rarely face a situation where you're going to deal with a single particle. Generally, you will be dealing with a group of particles. So first one is what? That is line charge. The charges, they are distributed along a wire. Okay. So I said that cable is the good example. Any cable you can take, either the lab one or the overhead cable. Okay. So there also similar situation is there. Second one is what I said, that the capacitor, when you're designing capacitor, then you're considering certain area because you have to get what? Certain capacitance. Okay. So certain capacitance, you're going to design it for certain voltage. Okay. So if you're applying certain voltage, then what amount of charge will get accumulated on this? So how much is the surface area? So all these parameters will be taken care at that time. Okay. So now the charges, they are distributed on the surface. So density, okay, because you are confining certain number of charge in certain areas. So it becomes what? Density. How dense the population of charge is. So how you'll come to know? By using this rho S concept. So Q divided by A. Okay. Okay. So now the volume charge. So volume charge. That printer का droplet, if it is very small, then otherwise वो single particle में consider कर सकते हैं. But if the droplet size is very large as compared to the size of the charge, then at that time you can consider the example of what? Volume charge density. Okay, so now it's rho V, Q divided by volume now, because they are not along a line or along a surface, but now they are going to spread throughout certain volume. So when I say volume, so thickness is involved. Like if you compare the earlier cases, line. So it's line only. Even though I have shown here what? It's a conductor. But when I talk about the line charge, so thickness is never ever taken into consideration. Okay, when you're designing a cable. So and you are doing electrostatic analysis. So at that time, thickness is never ever taken care. Only the length is taken care. Okay, because the length of the cable is very, very large as compared to the radius or the diameter of the cable. So we simply neglect the thickness. But when you're going to do the time varying analysis, okay, when you actually talk about the wave, see, there are two aspects, static and dynamic. So far we are talking about only about the static case. Okay, so static case may then thickness is not considered. But when you're going for the dynamic one, at that time the thickness of the conductor is taken into consideration. And when we talk about the surface, so surface, we are interested in the surface area. What is the thickness? So we assume that the thickness is 0. Simple reason is what? The thickness is very, very small as compared to the area. Okay, that's why we neglect that part. And there is another concept also, and one more parameter is involved there, but that we will talk later on. Okay, but here there is nothing like 0 thickness or 0 radius. Okay, volume is there, so definitely the radius has to be there. So if radius is there, it means the thickness is there. So the charge spread from origin to the surface of the this air. Okay, at every point there will be presence of charge. That's why volume is involved there. So coulomb per meter, that is the unit. So the distribution of charges: point charge, line charge, surface charge, and volume charge. Okay, in that line and line and surface charges, these two distributions are more important for engineers. Okay, now if the electric field intensity, as I said, that the electric field intensity plays a very important role in engineering field. Okay, so already we have seen what is the impact of the single particle in the surrounding, which we call as what? Electric field. So because of the single electric particle, in what way you can find out the impact created? That is what? Electric field created in the environment at certain distance. Similarly, now we have gone through what? 3 different charge distributions, right? So every charge distribution, because charge is there, so all those charges, they are going to influence the surrounding, right? So whenever charge is influencing surrounding, means you have to talk that influence in terms of what? Electric field only. So in what way or what will be the form of electric field intensity because of a line charge? So it is given by what? Rho L. L is not a length here. L is suffix there. So it is rho suffix L divided by 2 pi epsilon R into AR cap. AR cap, it represents the direction in which the electric field is existing. R is the distance from this line charge to the point where you are measuring the electric field intensity. But it's a line charge, no? So which point you will take actually? So, okay. Okay, later on I will talk about this using this tab. First, we'll go through the formulas. What are the formulas involved actually? So electric field because of a line charge will be given by rho L. L, once again, I repeat that it's not rho into L, it's rho suffix L. Charge density, line charge density. So L here represents that you're talking about charge density, but along a line. Okay, it's not into L. That is rho divided by L. Okay. So if you'll see the earlier this basic formula for the electric field intensity, that formula and this, they are same here, Q. Okay, so you just look at this. Okay, it is what? Q into Q. Coulombs, electric field we are talking. Okay, so it's Q divided by 4 pi epsilon R square. It is 1 by R square, 1 by per meter square. So if you look at the other equations, what are with the distribution? Okay, here. So here it's 1 by R. It's not 1 by R square, but the unit of this charge density is what? Coulomb per meter. So that per meter and this already per meter, it gets multiplied. So it becomes what? Per meter square. Okay, so the nature is going to remain same. Okay, but because it's a line charge, the field distribution is going to be totally different than the field distribution because of a single point. Now the surface charge. Okay, so field is normal to the surface. Whatever field will be radiated from the charges which are residing on the surface, no? That will be what? Perpendicular to the surface. But remember that once again, it's a hypothetical concept. Okay, because whatever field is there, and when the moment it is leaving the body, at that time it is perpendicular, but later on there is no guarantee it will remain perpendicular. Okay, so but whenever it leaves a body from the surface, it is perpendicular. Okay, and the field will be what? On the both side, right side and left side. You can see the red arrows, because the charges are there, so they will try to radiate in all possible directions. But because they are surface charges, they will radiate towards the left and towards the right if the sheet is kept in this vertical form, right? Now the formula here is what? Surface charge density. So rho s divided by 2 pi epsilon naught. Okay. So if you are knowing the surface charge density, then you can find out the field intensity. Now here there is involvement of distance is not there. Okay, so the meaning here is what? The electric field intensity, because of a surface charge, is going to remain constant. What will be the distance? You are standing in front of that sheet. Either you are very close to the sheet or you are far away from the sheet. The field intensity is not going to change. It will remain same. Okay, and this concept is used in this house lighting. अपना जो lighting system लगाते हैं हम लोग roof ceiling पे. So arrays of lights are used, just because if you are using the arrays of light, then the brightness is uniform and good brightness can be achieved. Okay. Now, if you are going to find out field intensities because of different distribution of the charges, then this is the formula. फॉर्मूला मेरे ख्याल से ना जब हम लोग एक एक करके न्यूमेरिकल लेंगे तो फॉर्मूला डिस्कस करेंगे तो ज्यादा अच्छा रहेगा. अभी सब फॉर्मूला एक साथ दिमाग में नहीं जाएगा. ओके ओके, इफ यू हैव एनी क्वेरी यू कैन आस्क.
Guys, our first tutorial is going to be based on this topic. That is some theoretical questions on Coulomb's law, followed by electric field problems. Okay, so if you have any doubts, please ask. Maybe next lecture we'll be solving the numericals, so that you will get some idea about how to solve the problems on infinite distribution of charges.
Sir, we are going to give this PPT in our GCR today.
Yes. All the PPTs will be shared on Google Classroom.
Sir, हेलो सर.
हाँ बोलो.
सरफेस का जो आपने फॉर्मूला बताया था ना, वो जो an था ना, वो क्या था?
ओके, मैंने इस पे फोकस नहीं किया. See, an is a unit vector. So here, if you look at, you just refer this diagram, okay? So you can see that this red arrow, which represents what? The direction of the electric field intensity leaving this charge. So one is on the right hand side, another is towards the left hand side. But both what will be the direction, but they are perpendicular to the surface, means normal to the surface. So an is what? It's a normal direction. Okay, an represents a vector which tells you the direction of the electric field. Since the electric field direction for a surface charge distribution is always normal to the surface, that's why an is written, and represents here normal here actually. Okay, or if you are aligning this sheet to some axis. So it can be AX, AY, or AZ. Now, the reason for having plus and minus, because you can see that the arrows are either on, they are on both the sides, right and left. So if you are considering that the right one is your positive direction, then the left one will be treated as negative, or the vice versa. That's why here plus and minus sign both are there.
Okay, sir, got it.
And one more thing I forgot to tell you, that in this equation, it is 1/2 is coming. Just because your entire field intensity is getting divided in two parts, left and right. That's why 1/2 is there. So if you are developing some mechanism so that the entire force and the entire electric field will be on one side only, so 1/2 will not be there. It will be rho s divided by epsilon naught.
So, sir, here we are considering from one side charge area.
No, see.